So what we've seen so far from just the alkanes, alkenes, and alkynes is that carbons can bond with each other in many ways. They can form triple bonds with each other. They can form more than one triple bond. They can form double bonds and more than one double bond. And in some cases, they could even form shapes like triangles, squares, and even, pentagons, etc. If we're thinking about line structures, remember that every point in each one of these, or every vertice, is a carbon. And so what closed shapes do is that they provide increased stability in the organic hydrocarbon. And so, like I just said, they provide increased stability. So you're more likely to see them as liquids or even solids in some cases. And these closed-shaped hydrocarbons are what we call cyclic hydrocarbons. And in terms of naming, you just insert cyclo at the beginning. And so let's say the compound has 4 carbons. You would normally call it a butane. If it forms a closed shape like a square, okay, so something like this, where each quarter represents a carbon, this would be called cyclo and then butane, assuming that it has no double bonds or triple bonds. Another important note, and I'll put a star beside this, is that the shape, right, whether it's a square or circle, doesn't really matter, not a circle, but a square or a triangle or a pentagon, the shape is always the parent chain, whether it's smaller than anything else attached to it. We don't have a naming system for cyclic side chains or branches. So it's always going to be the parent chain. The other rule that we're going to write when naming cyclic hydrocarbons is that for branches, okay, which are the hydrocarbon chains that are outside the parent chain, when it comes to branches, okay, we're going to start naming, okay, in alphabetical order. And this is more really in effect once you see, when there's more than one type of chain, okay, of branch, I should say. So you can start naming them in alphabetical order, and you number the shortest route to all the branches. Let me just write that a bit clearer. So to all the branches. So let's see how these rules are applied when we actually do some problems. So it says name the following. Now these are closed structures, both of them. They're both shapes. And by closed structures we mean that the carbons connect in a certain way that they form shapes. Just like in our line structures, each vertice or point is a carbon. Now there's 1, 2, 3, 4. That means there is 4 carbons, so it's butane, and because it forms a closed shape, we don't see any double bonds here. We're going to put the word cyclo in front. And so the first one here is cyclobutane. Now for the second one, we have 1, 2, 3, and 4. And so this is definitely a butane, and it's a cyclobutane as well because it forms a closed shape. but it also has a branch here and a branch here. Okay? The first branch, because it has one carbon over here, right? One vertice. This is going to be a methyl. And this one over here has two vertices, one over here and one over here. So this would be an ethyl. Now, we begin counting from the branch that is alphabetically first. And then I'm going to go to the shortest distance to the next branch. What that means is I'm going to start here because ethyl starts first. But instead of going 1, 2, 3, 4, that isn't the shortest distance to the next branch. The shortest distance to the next branch is this way. So it'll be 1, 2, 3, 4. So when I name this, it'll end up being 2-ethyl. Oh, sorry, not 2-ethyl. I meant 1-ethyl. Sorry if that's going to confuse you. 1-ethyl dash 2-methyl. And then, because it is a closed shape, it'll be cyclobutane. Now, looking at this one here, we got 1, 2, 3. Remember that the rule is that the shape is always going to be the parent chain, even if it has less carbons than whatever else is attached to it. So here we got 3. So this is going to be a propane. It'll be a cyclopropane. Now, the branch over here, okay, has 1, 2, 3, 4 carbons. And we're always going to commence counting from the branch. So this would be 1-butyl. And so the full name for this one would be 1-butyl cyclopropane. Lastly, just because they're cyclic, it doesn't mean they can't be alkenes or alkynes as well. And so here, this double bond would make it a cycloalkene. And I would proceed as usual. I would identify just how many carbons are in the parent molecule. In this case, there's 4. And I start numbering from the side that is closest to the double bond. In this case, we're going to go like this. We're going to start from here. So this is 1, 2. And this is an ethyl. So we're going to go this way. 1, 2, 3, 4. And here is a methyl. And so when we name this, this would become 3-ethyl, 4-methyl, cyclo-but-1-ede. And in fact, sometimes, in some cases, because the rule is, when it comes to cyclic hydrocarbons, is that you always have to count from where the double bond occurs at. Some people say, well, then it's useless to put the 1. And so they may, in certain answer keys, just write cyclobutene. And that is fine as well.